understand this idea over here. We know it is Doppler effect. So here there is no effect, whereas here it is. So basically it is when an there is a change in frequency or wavelength of a wave when the source of a wave is moving towards or away from the observer. Yeah, as you can see right there, as it's moving away or towards the observer, it will have a change in frequency and as well as wavelength. As you can see, the wave is more compressed, whereas here it's far away, and here it's stationary. So both of them here at the same rate, both here the same frequency. Now since the object is stationary here, the speed will be v, and that's the speed of the wave. There's nothing going on. And now when it's moving away, there is an added speed right here. This added speed is the speed of the source. So this is the velocity of the moving object. Thus we take the speed of its motion of the vehicle or an object. Now for this is basically talking about this here, 12b. So situation is different when the observer is moving away, receding from the observer. It's moving away from the observer, as in here. In 1 second the source moves a distance of vs. Now the section of fs, which is the source by the way, wavelength will have length equal to velocity of the wave plus vs, the source. So you can understand the wavelength from what it was before. Here it's stationary and the wavelength was here, but when it has an added speed, it becomes there. So this is the velocity speed of the wave, and when the speed of when their object is starting to move away from the object from the observer, it increases. So whenever speed of, it's like this motion of an object which like the motion of the object controls, you could understand it as the observed speed, so which you will observe it. So it's like the source of the speed of the source is affecting the speed of the wave, and thereby at one point if it was stationary you would just hear the speed of the wave, but somehow when it's moving away you could see that it increases. In a sense, the speed of the wave and the speed of the source, so v plus vs, will give a new wavelength, and this observed wavelength will, this bigger wavelength will now be experienced by the observer. As not only is there a speed adding onto the source, thus becoming bigger, and the wave thus becoming bigger, thereby in that sense it can be said for the opposite. So opposite could be true. As it's moving towards the observer, it takes away the speed of the sound, so it reduces the wavelength. Basically the rate at which the sound is heard becomes more frequent, and wavelength is becomes shorter. I hope that makes sense. Some honorary mention of some ideas to perhaps may influence you. So the source of the light of a laser beam light is this one, let's say, and it's stationary and light goes on forever. And let's say the source moves at the speed of light. If the source of the beam moves at the speed of light, the same speed as it is, you would expect the light to be around here because it's going at the same speed as this. Instead of seeing the light over here, you would see it here, but you can't see in the speed of light. Let's say you could, and let's say light was like a waterfall, and we could see water falling down, yeah, but what if it was like already fallen? If it was moving at the same speed, maybe we would see it like a waterfall going down, but the light, the source of the light, you could say the source of the water wave, let's say in the bucket, is still in the bucket. Yeah, the water is still in the bucket because it's moving at the same speed as the water. But I have another thought into another fire that may bring hope to the mind, perhaps controversy, but let's say, what if it pushes the wave? What if the object pushes the wave? Will it go now even faster? I don't know, perhaps might make sense for this, but I don't think it would have enough force to oppose, because it's light wave, it perhaps would phase through. I'm not sure if phase, but You can make up whatever you want, but those two ideas is what I want to present, and hopefully you could understand this. See you all.